Tashi, and I set out to make myself a cup of coffee by building an induction cooktop, which more or less went to plan. I filmed the whole construction and testing in time-lapse and still ended up with far too much footage to use, so you'll see the final moments of the practical demo and my explanation of the project with a nested time-lapse of the construction and testing. And there'll also be some text notes throughout the video as needed, but I hope you enjoy.
It got just to above about 80 degrees Celsius, which is as high as I want to let it get, because I live in Santa Fe, New Mexico, which is at about 7,200 feet, 2,200 meters, and water boils around this point, so I don't really want to let it get any higher. I went ahead and unplugged it, so that way this is safe to be around, and I do just want to demonstrate that, I'm going to take this off the stove, deal with that in a second. I do just want to demonstrate that this, even through the glove, not hot at all, I can touch this with my hand, and the surface is just warm, and that's because the kettle was sitting on it. I used this silicone baking mat for cookies, which is not very good at heat transfer. If you've ever had not crisp chocolate chip cookies cooked on these, you know what I'm talking about. But this was just to really protect the insulation on this wire coil here. I know I said I was going to make coffee, but I honestly can't find my pour over coffee funnel, and I've had too much coffee today anyway, so I'm just going to make some tea with this. Let's talk about the circuit. So this is really the important component here. This spiral is the induction cooktop. So the way this works is that we have just a ton of current coming in through this side, and I'll get to the transformer in a moment, but we just have a ton of current going through this spiral, and that creates a magnetic field, B field, with a pretty high intensity. And because I used that very thin silicone baking sheet, the kettle could use a lot of that B field. So what happens here is the current comes through, the B field is induced surrounding this spiral, and then that causes eddy currents to be induced in the bottom of this kettle. Now, because this kettle is induction cooktop friendly, it's a pretty good conductor of heat, but it is a very bad conductor of electricity. So those eddy currents, which are switching directions at 60 hertz and causing resistive losses within the bottom of the kettle, which is then converted to heat energy, and that's what was heating the water. In terms of the circuit, the inductive spiral itself has 9 turns throughout, and this came out to just under 7 micro henries. And then I had to add some jumper cables in series just to increase the overall impedance of the low side of this circuit so that I didn't surpass the rating of this wire, which is number 4 gauge THHN. So that was rated for 95 amps. I did have an ammeter on the low side during startup while I was testing, and it read 67 amps. I didn't want to run out the battery, so I turned it off. Let's also talk about this transformer, which is what allowed me to not actually have a power supply because I don't have a power supply in my house. So I made this 20-to-1 transformer with a ring magnet that I got off of Amazon. So the low side, there's 1 turn, and the high side has 20 turns. And then the line and neutral of this power supply plug that I got at Home Depot is just connected here with a properly rated terminal block. Like I said, we had about 67 amps flowing through this spiral, and so that should have been about 3.35 amps on the high side. So 120 volts was coming in, 6 volts was coming out on the bottom. But yeah, this was my induction cooktop. It was a lot of fun to build. I hope to never power it on again because I did trip a breaker, and I was really worried that I was going to screw up the electrical in my house if I left it running longer than it needed to. And it did take a while to heat up this water from 30 degrees Celsius to about 85 degrees Celsius, and I did not want to let it go any longer. But thanks for watching, and happy midterm season.